Hi, and welcome to the USMLE Step 1 Immunology. I'm Dr. Kim Muscatello, and I have with me the co-author of this edition of the Immunology book, Dr. Tiffany Alley. I'm going to let her talk to you a little bit about the changes we made this year to the book, and then we'll go ahead and get started.
Well, everybody, our approach to the book is a little bit different this year, and what we have tried to do is structure the material to better reflect what is actually going on as far as timing with the immune response. We really want you to recognize that the material for both the innate immune response and the subset of T helper cells has expanded tremendously and in some aspects has completely changed. And these changes reflect what is currently going on in the field of immunology.
Dr. Alley and I have worked together for a long time. We're actually really good friends. We had an amazing time writing this book for you, and we hope that you enjoy this journey with us.
Hi, this is Dr. Alley, and I'm going to be taking you through your first chapter of immunology today. This first chapter is a really nice way to start out. We're just going to go through and remind you about some of the details of the innate and the adaptive immune response. And this basic information should hopefully help you as we go through some more challenging aspects of immunology. So when you think about the immune response, most individuals are going to say, well, hey, the immune response really is just about the body discerning between self and non-self. We really want you, though, to keep that in mind, but sort of expand your view of the immune response. And what we want you to see is that the immune response really recognizes multiple things. It typically is thought of as dealing with diseased cells, but what about the cells that are damaged or distressed or dying? All of those cells are also addressed by the immune response and are going to be eliminated. When we think about the immune system, we are always going to talk about them being divided into two complementary arms, the innate and the adaptive. We really are going to stress, though, that these two arms are not mutually exclusive from one another, but rather provide each other with necessary signals to clear an infection. The innate immune response is going to provide us with our first line of defense against a variety of pathogens. There are going to be several barriers that are going to comprise the innate immune response. First, and probably what I think is the most important, is the simple anatomic barrier that is presented by the skin and mucosa. Once that, though, is compromised, we're going to have a couple of really good backup plans, including some of the physiological aspects of defense. Complement being in the humoral aspect. Let's go ahead and add in there our phagocytes and our granulocytes. And when you put all of these things together, really what you're going to do is have the presentation of inflammation. So inflammation, sometimes viewed as a very bad thing, really is critical for the clearance of an infection. The characteristics of the innate immune response are both reflective of its strengths as well as its limitations. As the strength, it's always on. The term present intrinsically is going to say, hey, I'm here, I'm ready to go, just activate me, which is going to be very important when I'm trying to immediately respond to an infection. But here are some of the limitations. The innate immune response does have limited specificity. It is only capable of recognizing shared patterns or structures among the different pathogens. Due to this limited specificity, you're going to also see limited diversity, as these cells also have a limited number of receptors that recognize these different patterns. The other thing that really puts the innate immune response at a disadvantage over the adaptive immune response is that there is no memory. So every time the innate immune response sees a pathogen, it's going to respond with the same amount of vigor that it did initially. The second arm of the immune response, adaptive immunity, is comprised of two cell types, the B and T lymphocytes and their respective effector activities. B and T lymphocytes have several characteristics that differentiate them from the cells of the innate immune response. Each cell of the adaptive immune response is specific for one and only one antigen. So as you look at the population, what you have to recognize is that the populations of cells show extreme diversity. Another very important aspect of the adaptive immune response is that the response is heightened with every single exposure to the pathogen. So the response you have the second or third time to a pathogen is much more robust than the initial response that you had. And this is based on the fact that each response generates a certain number of memory cells that will exist long enough to deal with a secondary or subsequent response. Also very important here is that the B and T lymphocytes are able to distinguish between self and non-self. Now we all know that this isn't 100% true, otherwise we would never see autoimmune disease. And I think this is an aspect of our lymphocytes that are pretty reasonably overlooked, but what I like to say is that the minute you turn on an adaptive immune response, the adaptive immune response is trying to turn itself off due to the very high level of proliferation associated with activation. This table is great for comparing and contrasting both the characteristics and the components of the innate and adaptive immune response. And I would recommend that you reference this particular table when you are reviewing the material for Chapter 1.
It's important to understand that both the innate and the adaptive immune system come together to help eliminate infections. They don't live separately on an island and never talk to each other. However, sometimes, once a pathogen is capable of breaking through the anatomic and or physiologic barriers, the innate immune system responds fast enough to sometimes contain the infection and eliminate the infection, really sort of eliminating the need in certain cases for adaptive immunity. There's sort of the way you want to think about innate immunity is like the front line. Obviously, we're here because sometimes the innate immune response is not capable. In fact, more often, the innate immune response is not capable of handling a pathogen completely by itself, and therefore we need the help of that specific immune response, which comes by way of adaptive immunity. But here's the issue. It takes about 1 to 2 weeks after the primary infection for the adaptive immune response to really become activated and to really help clear the antigen by way of effector cells and antibodies and all kinds of stuff that we're about to talk about. So that innate immune response is really important early response, and it helps really keep the host alive while the adaptive immune system is gearing up this highly specific army of cells and antibodies that can help eliminate any infection. Now, one of the things that is also important to understand about the immune system is, of course, remember, we have this whole system inside of us that's designed to kill things and somehow draw a fine line between self versus non-self. So there is really a lot of control mechanisms that the immune system has in order to turn itself off. So it's what we call self-limiting. Once we have an infection and that infection has been cleared, both innate and adaptive immunity turn themselves off. Now, as far as adaptive immunity, we have antibodies and residual effector cells like T cells and B cells that provide immunity. And then we have these long-lasting memory cells that really survey the body looking for that same antigen again to protect us from subsequent infections. Again, here's the key point, with the same pathogen. Remember, the immune response, particularly when we're talking about the adaptive immune response, is highly specific.
Another excellent resource from Chapter 1 is the timeline of an immune response. Now, with this particular timeline, what we're looking at is an acute response to infection. So as you look at it, remember that once I have a pathogen get into my system, it is going to be the innate immune response that is going to be immediately activated. So again, the innate immune response is going to be the first employed arm of the adaptive immune response. Typically, the innate immune response is going to be able to contain and eliminate a pathogen all on its own. But in the cases where that pathogen is going to increase its numbers to a certain threshold where the innate immune response is no longer able to contain the infection, the adaptive immune response is going to have to be engaged. So it is the innate immune response collaborative effort with the adaptive immune response that will activate my B and my T cells. A very important time frame that I'm going to ask you to remember is that it takes approximately 1 to 2 weeks to get a full-blown adaptive immune response versus the immediacy of an innate immune response. So after the infection is being cleared, you have to consider that all the cells that were generated in the primary immune response are going to have to either undergo apoptosis, or the ones that survive will be reflective of our memory cells. And those memory cells are going to go on to respond to a secondary or a subsequent infection with the same pathogen. At the end of Chapter 1, you're going to find this particular figure. At this point, it's not necessary to memorize all the details, but rather what we would ask you to do is to revisit this particular figure as you go forward. As you can see that the interaction between the innate versus the adaptive is one that is collaborative. As an example of this, notice that within the innate immune response, we have phagocytes such as macrophage or dendritic cells that are going to produce cytokines. These cytokines will act upon the T lymphocytes of the adaptive immune response, and in turn, the T lymphocytes will produce cytokines. These cytokines can work on multiple pathways, but of note is how these cytokines will actually go around and have feed forward or positive feedback on the cells of the innate immune response, enhancing their activity. So we would like you to look at this interaction not as two independent processes, but as a amplification.